Hello everyone. The title of this video is Graph Quadratic Functions Using Properties. Each exercise I'm going to do in this video is taken directly from a free online textbook at openstacks.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 9.6 titled Graph Quadratic Functions Using Properties, right, just like the title of the video. And I'll be working under the heading of the same title. I'm only going to be working on the even numbered exercises, so 254, 256, 258, and so on, until 270 in this video. Alright, and the even numbered exercises are ones that don't have solutions in the text. You may notice that the odd numbered problems have links on them that you can click on and see the solutions for those, so that's why I'm not doing those. Right. I will also have timestamps for these exercises I'm doing in the description of the video below. The example 1 timestamp will be for the start of number 254, example 2 for 256, and so on. And one request I make of you is that when I start a new question, pause the video and try to do it yourself first before watching me do it and comparing. Because if you're just watching me do these things and not practicing yourself, chances are you're not learning all that much. Alright, so the instruction for all of these is graph the function by using its properties. So I'll explain what that means and talk about how we're going to go about graphing a general quadratic function, starting with number 254, which I have written out. So example 1, exercise 254, we're asked to graph the function f of x equals x squared plus 4x minus 12. Alright, so before I actually get into this example specifically, I want to, on a separate piece of paper here, talk about how I'm going to go about graphing every single one of these functions. So given f of x or g of x or y equals a standard quadratic polynomial, a times x squared plus b times x plus c, right, where a, b, and c are real numbers, and of course a is not 0, right, because if a were 0 it would be a linear function and not a quadratic function. Alright, the first thing I'll do, the first step, is I'm simply going to determine if the parabola opens up or down. Alright, just so I know that when I look at the graph later, I can tell if I did something right or did something wrong. So I'm going to determine if parabola opens up, right, so like this, like a smiley face, or down, right, like this, frowny face. Right. And that's simple. You just look at the lead coefficient. Right. The a, right, the coefficient of x squared. The parabola will open up when a is positive, when a is greater than 0. And the parabola will be opening down when a is negative, when a is less than 0. Okay, very simple to determine that straight away. Okay. Next, going to find the axis of symmetry for the parabola. The axis of symmetry. And this has been brought up in a previous video. Now I'm going to, for the rest of this video, abbreviate axis of symmetry as AOS, like this. Axis of symmetry. This is a vertical line. This is going to be a vertical line that, cuts the parabola in half, if you want to think about it that way. Alright, so remember, if it's opening up or opening down, no matter which way it's opening, it's going to have this axis of symmetry. And I'll do a little dotted line here, because the axis of symmetry isn't actually part of the parabola, but it's a vertical line that cuts the parabola in half. If you were to fold the paper along this vertical line, the right half and left half would match up perfectly. Right? Same thing for if it opens down. The equation for the axis of symmetry, right, a vertical line, so it's x equals some number, is going to be x equals the opposite of b, right, where b is the linear coefficient, divided by 2 times a, right, where a is that constant. Not the constant, a is the coefficient of the quadratic term. Right. So I'll highlight this, put it in a bubble or something. All right, and again, this should be familiar to you. Alright, then once I have the axis of symmetry, I'm going to find the vertex of the parabola. Now the vertex is either the lowest or highest point, depending on which way it's opening, of the parabola. And it's also the point of the parabola that's on the axis of symmetry, right? So this would be the vertex if it were opening up. And you see when it's opening up, the vertex is the lowest point. And this would be the vertex if it were opening down. And hopefully you can see that when the parabola opens down, the vertex is the highest point on the graph. Well, it's a point, right? It's a point, so it has an ordered pair. It has coordinates, an x value and a y value. The x value, right, since it is on the axis of symmetry, we know the x value. It's that negative b over 2a. And then I just plug this into the function and get the output, and that'll be the y coordinate, f of negative b over 2a. Right, sorry about the clutter there, but f of negative b over 2a, just take negative b over 2a and plug it into the function, and you'll get your vertex. Alright, so that'll be one point on the graph. Then, just to stay consistent with what the text is teaching, I'm going to find some other points on the graph as well. Find the intercepts, right, which was done in a previous video as well. Right? Find the intercepts. Right? This is the x-intercepts and the y-intercepts. Right? So I'll put that, x and y intercepts. Now don't forget that sometimes a parabola has no x-intercepts. Alright, so just be careful with that. Then finally, and I've done this in a previous video as well, find a point on one side of the axis of symmetry and use it, use the symmetry to find another point on the other side. So find a point on one side of the axis of symmetry, which again I'm abbreviating just AOS, and use symmetry to find a point of the parabola on the other side as well, on the other side of the axis of symmetry. Find a point on the other side. And then the final step would be just a graph. I know this is tiny here, I apologize. Then, complete the graph. After you've done all the first 5 things, you should have plenty of information down on your coordinate plane to be able to make a rough sketch of the graph of the parabola. Okay? Alright, so looking back here, example 1. Notice I'll write down what, it's in that standard form, f of x equals ax squared plus bx plus c, like I have here. The value of a would be positive 1, right, the coefficient of x squared. The value of b would be positive 4, the coefficient of x to the first, the linear coefficient. The value of c is the constant term, negative 12. And notice, right, that the lead coefficient, the a, is positive. So that means that the parabola is going to be opening up when I'm done drawing it. Right? It's going to be a smiley. All right, but it's got to open up. All right. So if you're done drawing this and it's opening down, but you had a positive lead coefficient, then you know you did something wrong. All right. All right, so next is find the axis of symmetry. Right, so the AOS, right, axis of symmetry, has the equation x equals the opposite of b divided by twice a. So that's negative 4 in the numerator, and then 2 times a is 2 times 1. That's 2 in the denominator. Negative 4 divided by 2 is negative 2. All right, so what I'm going to do, and I'll just kind of bubble this in. This isn't the final answer. I mean, I have to graph the thing. But what I'm going to do with this is on an xy plane that I'm going to make a rough sketch with by hand. Right? So over here, there's horizontal x-axis, vertical y-axis, or you could call it the f-axis, because f of x is the output. I'm going to go to x equals negative 2, right? So negative 2 on the x-axis, there it is. And draw this vertical line. Now don't draw a solid line. I like to draw a dotted line because this line is not actually supposed to be there. Right? It's not actually part of the parabola. But it will cut the parabola in half. Right? It will have the vertex of the parabola on it. So there's the line x equals negative 2. All right, then the vertex. Find that vertex, which, if this is opening up like it should, this is going to be the lowest point of the parabola. Alright, so the x-coordinate of the vertex is negative 2. Right, you get that from the axis of symmetry. And then the y-coordinate would be, what's f of negative 2. Right, so I need to plug negative 2 into this function and see what the output is. So that'd be negative 2 squared, right, plus 4 times negative 2 equal minus 12. Right? And this is 4, plus negative 8, so minus 8, and then minus 12. This is negative 16. All right, negative 16. So the vertex is at the point negative 2, comma, negative 16. And again, I'll bubble this. This is important. Alright, now I'm not going to draw 16 individual notches here, so what I'm going to do is I'm going to say that each notch on the y-axis is 4 units, so that's -4, then -8, -12, and here's -16, right? So the vertex, which I'll plot, -2 input, -16 output, there it is. Pardon me. That's going to be the lowest point on this graph. Right. And if the vertex is below the x-axis, and we know it's going to be opening up, then the graph is definitely going to have x-intercepts, right? It will hit the x-axis. And that's what I want to find next. What are the intercepts? Right, so we have the axis of symmetry, got the vertex. Now for the intercepts. Alright, so first, the easy one, the y-intercept. Remember, y-intercept, you have an x-coordinate of 0, and then, what's the output when the input is 0? So if I plug in 0 for x, you'd have 0 plus 0 minus 12. That's just -12. Right? So there's the y-intercept, and I'll plot that. Right? 0, -12. 0, -12. There it is. Right? On my drawing, my hand drawing. Then the x-intercepts, again, you've seen this in a previous video. You're solving the following equation. Right, x-intercepts have a y-coordinate of 0. When is the output equal to 0? When is f of x equal to 0? Right, and then you solve for x. You find what values of x give me an output of 0. So when is x squared plus 4x minus 12 equal to 0? Pardon me. Now you could solve this with the quadratic formula. You can solve it by completing the square. But this one here is actually factorable. This factors to x plus 6 times x minus 2. Right? And so the solutions of this equation are -6 and +2. Alright, so the x-intercepts are -6, 0 and +2, 0. Right? Now plot these points. So sticking to the spacing I've used here for the x-axis, there's +1, +2. There's 2 on the x-axis. 2, 0 is this point. And then -6, right? So again, keeping the same spacing, I'm trying my best. 3, -4, -5, there's -6. -6, 0. Alright. And then finally was, find a point on one side of the axis of symmetry and use the symmetry to find a point on the other side. Well, that's already done. See, this point 2, 0 is on the right. -6, 0 is on the left. See how those are both 4 units away from the axis of symmetry? 4 units to the right, 4 units to the left. Now I could do the same down here, with this y-intercept. The y-intercept is 2 units to the right of the axis of symmetry. So if I go just 2 units to the left, I'll get another point on the parabola, which would be at -4, -12. Right? 0, -12. I go 2 units to get to the axis of symmetry, go another 2 units to get another point on the parabola. There's the ordered pair -4, -12, right? Also on this parabola. And that should be enough. Right, and I guess I should have said that down here, right? Then use symmetry for other points, right? Then I'm using symmetry to find other points. Now let's graph. Right? Now that I have these 5 ordered pairs plotted, we can get a rough shape of the parabola. Right? So the parabola, again, make sure that you're not, parabolas aren't pointy at the vertex. They're more curvy. They flatten out. So please don't make it pointy. That's all I ask. And then just kind of follow through to the other points here, filling in the rest of this parabola shape. arrow going up for there, up that way forever, up that way forever. And there we go. All right, there's a nice rough sketch of the graph of this quadratic function, the graph of this parabola. All right, now let's take a look at another picture, a better picture, on a graphing calculator. Now this is a free online graphing calculator. You've seen me use it in other videos. It's at a website called desmos.com. And I'm just going to enter the function we were given. Right, it was f of x equals x squared plus 4x minus 12. And look at all the points that are highlighted here. You know, there's negative 6, 0, an x-intercept. 2, 0, another x-intercept. Right? Scrolling down, you can see where the vertex is. Right? See this point here, negative 2, negative 16, which we also plotted. There's the y-intercept, 0, negative 12. And then you see on the other side, 4, negative 12. Oop, should be there eventually. You know what? I can just put in the point. Ordered pair 4, comma negative 12. Not 4, negative 4, negative 4, negative 4. Right. And there, see, there's that point 4, negative 12. Negative 4, negative 12. And I can put in the axis of symmetry, right? X equals negative 2 and make it a dotted line. Let's make this a dotted line because it's not actually part of the parabola. Okay, and then you can see the symmetry about this line, right? Again, the vertex at the point, you know, negative 2, the vertex is on the axis of symmetry. There's 0, negative 12, which is 2 units to the right. And then if you go 2 units to the left, you're at that negative 4, negative 12. Right? And the same thing for the x-intercepts, you know. See, this x-intercept is 4 units to the right of the axis of symmetry. The other x-intercept is 4 units to the left. Right? Parabolas are symmetrical about some vertical line. Right? I'm hoping that's obvious here. And this looks pretty close, very, very close to the drawing that I made by hand. Right? So it looks like I did a good job. Pardon me. Alright, so let's do that again, and I'm doing this every single problem, following the same steps. Alright, so next question. Again, we are asked to graph, right, the following function, quadratic function, the following parabola. F of x equals x squared minus 6x plus 8. Right, so again, the value of a would be positive 1. The value of b would be negative 6. Don't forget negatives. And the value of c would be positive 8. The lead coefficient is positive, so this parabola is going to open up again. All right, just making that note to myself. So when I graph it later, you know, if it's not opening up for some reason, then I know I did something wrong. The axis of symmetry, right, AOS, is x equals, you know, the opposite of b, which would be positive 6, divided by 2 times a, which would be 2, x equals 3. Right. So on the xy plane, I'm going to go to x equals 3, 2, 3, and draw a dotted vertical line. And this is the x-axis of symmetry, the line that, you know, cuts the parabola in half, you know, runs through the vertex. Right, there's x equals 3. Now the vertex. Well, I know it's going to have an x-coordinate of 3, and now I just need to find f of 3. All right, what's the output when the input is 3? Alright, so that'd be 3 squared minus 6 times 3 plus 8. That's 9 minus 18 plus 8, which would be negative 1. Right, negative 9 plus 8. Alright, so input 3, output negative 1. There's the vertex right here. And look, the vertex is below the x-axis, and it's going to open up. So I can tell right away that the graph is going to hit the x-axis. There are going to be two x-intercepts, which is what I'll get into now, finding the intercepts. Alright, so the y-intercept is easy. Just plug in 0 for x, and you would get, 8 for y. So 0, and then 1, 2, 3, 4, 5, 6, 7, 8. I'm trying my best here to keep things with the same spacing. So there's 0, 8. And then we can use symmetry to find another point later. Now I want the x-intercepts. So again, the x-intercepts, I'm trying to solve the equation, f of x equals 0. When is this expression equal to 0? So when is x squared minus 6x plus 8? When is that equal to 0? So again, you can use a quadratic formula, completing the square. This is another factorable one though, so I'm going to factor it. This is x minus 4 times x minus 2 equals 0. So the solutions to this equation are positive 4 and positive 2. Alright, so the x-intercepts are 4, 0 and 2, 0. Right. So input 4, output 0, input 2, output 0. So this point here is an x-intercept. This point here is an x-intercept. Great. And now I'm just going to use symmetry. Now I'm going to use symmetry to find points on either side of the parabola, right? On either side of the axis of symmetry. So here's, now these 2 points are symmetrical across the line, right? Both the x-intercepts are 1 unit away from the axis of symmetry, 1 unit right, 1 unit left. This point here, right, this is 0, 8. That's 3 units away from the axis of symmetry. So that's 3 units left. So if I go 3 units right, I'll get another point. Now 3 units to the right of the axis of symmetry would be at x equals 6. So 0, 8's on one side, 6, 8, and I'll write the ordered pair here, 6, 8, would be on the other side, right? And you can test that out. Test it out. Replace x with 6. You have 36 minus 36 plus 8. That'd be output of 8. 6, 8 is a point on this graph. All right, and now that I've plotted the vertex, I've got some intercepts, I've got points on either side of the axis of symmetry, I should be able to make a rough sketch of the parabola. And again, please make sure that it's not pointy at the vertex. All right, so something like this. Again, trying to keep it smooth the best I can. Same thing this way, right? Trying to make it look like the other side as well, right? Trying to use symmetry. All right, and there we go. There's a nice rough hand drawing of this parabola. All right, and once again, I will pull this up, enter this function into the Desmos calculator. So we had f of x equals x squared minus 6x plus 8. And look, the vertex, 3, negative 1, exactly what we got. X-intercepts, 4, 0, 2, 0. Y-intercept, 0, 8. And look at this point over here is 6, 8. I'll eventually get it. There it is. 6, 8 on the other side of the axis of symmetry, right? And again, the axis of symmetry, x equals 3. And you can see that blue line that just popped up. Now I can make it a dotted line, right? Just because it doesn't actually belong to the graph. It's not actually the parabola, right? See, it cuts this parabola in half, runs through the vertex, and all that. Pardon me. Wonderful. All right, and our drawing looked good. Okay, great. So next question. Doing the same stuff every single time here. So another quadratic function, another parabola that we're asked to graph. So f of x equals, and then again it's a nice quadratic polynomial in standard form, ax squared plus bx plus c. If it's not in that form, put it in that form, right? Multiply things out and put it in that form, ax squared plus bx plus c. So a this time is -1, right? The lead coefficient. B is +8, and c is -16. So this time, see, the lead coefficient is a negative number. This parabola is going to be opening down. All right, so when I graph this thing later, it's got to be opening down. And the vertex will be the highest point on the graph. All right, next I'll do find the axis of symmetry, AOS. That's x equals the opposite of b, right, so -8 in the numerator, divided by, and then 2 times a. 2 times -1 is -2. And -8 divided by -2 is +4. All right, so x equals 4 is the equation of the axis of symmetry. So again, I'm going to put a little xy coordinate plane over here. Go to x equals 4. Each of those notches is 1 unit. And I'm going to draw a vertical line, a dotted vertical line at x equals 4 here. This is the axis of symmetry. X equals 4. And the vertex will be on this line, which is what I'll find next. The vertex is going to have an x coordinate of 4, and then I need to find what's the output, what's f of 4. Right. So that's -1 times 4 squared plus 8 times 4, and then -16. So this is -16 plus 32 minus 16. That's 0. That's 0. So the vertex is on the x-axis. The vertex is my x-intercept. Right? So this is it's the only one. If the vertex is on the x-axis, that's going to be your only x-intercept. Right? Because look, there's the highest point of the graph, and it's going to be opening down from here, right? So no other part of the graph is going to touch the x-axis. That's got to be the only x-intercept. I hope that makes sense. All right, so then the intercepts, the only one I'm going to find is the y. Right? The y-intercept is 0 for x and -16 for y. Right? If x were 0, clearly the output would be -16. So again, I'm not going to go down 16 notches here. I'm just going to have my notches represent 4 units. So this is -4, -8, -12, and -16. Right, we'll say the y-intercept is here. And as I said, this is already the only x-intercept. I don't even need to solve the equation -x squared plus 8x minus 16 equals 0. But if you were to solve it, the only solution would be x equals 4. Right, the x-intercept is 4, 0. Already found it. And then I'm going to use symmetry. Right, use symmetry. And if you want to find other points, that's fine too. Right, if you want to plug in 1, plug in 2, plug in 3, something other than 4 or 0, ones that we've already used. You can plug in any other number, find another point, but really, as long as you have the vertex and one other point, you should be good. Use the symmetry here. The y-intercept is 4 units to the left of the axis of symmetry. So then I go 4 more units, 4 units to the right, to where x equals 8, and I get another point on the graph. So you have 0, negative 16, and then over on the other side of the axis of symmetry, right, reflecting across, you'd have the ordered pair 8, 8, negative 16. Right, and I leave it to you to check that. Plug in 8 for x, and you'll see the output will be negative 16. Alright, so now that I have a vertex and some points on either side, we can make a rough sketch of this parabola, right, going through these points. And again, just don't make it pointy. Right? It's not pointy. And continuing down, trying to get both sides to be symmetrical here, but there you go. Right? There's your parabola, right? Or at least a rough sketch of the parabola. Great. Right, and once again, I'm going to go to the Desmos website, enter that function. We'll take a look and see if if it actually looks like the graph I drew by hand. So we were given f of x equals negative x squared plus 8x minus 16. And look at that, right? The x-intercept and the vertex 4, 0. And then scrolling down a bit, the y-intercept 0, negative 16. And look on the other side, there's 8, negative 16 on the other side, right, when I reflected across the axis of symmetry, which was x equals 4, right, x equals 4. See that purple line that just showed up? I'll make it dotted. Yeah. And you can see the symmetry across that line. Great. All right, so our hand drawing was good. All right. Next question, same stuff. Same stuff every time. Alright, so this is again in that form, f of x or y equals ax squared plus bx plus c. Notice there's no x term. So all that means is, a is positive 5, right, the coefficient of x squared, and b is 0, right, there's 0x. So the linear coefficient is 0. And then c is the constant term, positive 2. So first thing I'm noticing, right, the lead coefficient is positive. So this should be a parabola opening up. Right, it's going to open up. The vertex will be the lowest point. So let's find the axis of symmetry next. Right, AOS. X equals, the opposite of b. Well, the opposite of 0 is still 0, divided by 2 times a, which is 10. And 0 divided by any non-zero number is 0. So that's the y-axis, right? X equals 0. The y-axis is going to be the axis of symmetry. Right, so yeah, x equals 0 is simply the y-axis. Right? You probably can't see too much of this, but x equals 0. The y-axis is going to cut the parabola in half. So the vertex is the y-intercept. Right, when I find the vertex, it's going to be 0, right? 0 for the x-coordinate. And then I plug in 0, you get 2. So the vertex is at 0, 2. So 0 input, 2 output. And that is the y-intercept. Now look at this. The vertex is above the x-axis. And it's going to be opening up. Right? So if I start from the vertex and go up, parabola shape, see how that graph is not going to hit the x-axis. So, the vertex is the y-intercept. Cool. And when I go talk about finding the intercepts, there are no x-intercepts, right? Because the vertex is above the x-axis, and it's going to be opening up. Now, if you didn't see that right away, you could try solving, when is 5x squared plus 2 equal to 0? And you'd end up with x squared equals negative 2/5. And the solutions to this would be plus or minus, the square root of negative 2/5 would be the square root of 10 divided by 5 when you rationalize the denominator, times I. Remember, the square root of a negative number is not real, right? It's imaginary. And if your solutions to that equation, where is the y coordinate 0? Where is the output 0? If your solutions are not real, that tells you that the graph doesn't have any x-intercepts, right? Because remember, the x-axis is a real number line, no imaginaries. And so if you end up with imaginary solutions, then there are no x-intercepts. Well, gee, that doesn't help me all that much. So all I have right now is a single point, and I know where the axis of symmetry is. So in order to be able to use the symmetry, I need to find a point on either side. All right, so let's find a point. Let's find another point, since the intercepts didn't help. There aren't any x-intercepts. Let's just find another point. All right, so how about if I plug in 1? All right, something else, plug in something off of the axis of symmetry. Plug in x equals 1. You get 5 times 1 plus 2, that's 7. So input 1, output 7. And now I can use the symmetry. All right, now I can use the symmetry to find another point on the other side of the axis of symmetry. All right, this point 1, 7 is 1 unit to the right of the axis of symmetry. So I just need to go 1 unit to the left to find another point. So input 1, output 7, input negative 1, output 7 as well. All right, there's negative 1, 7. And you could check that out. If you replaced x with negative 1, you'd get an output of 7. And that should be enough, right? Once you have the vertex and a point on either side of the axis of symmetry, you should be able to make a rough sketch of the parabola. So it'll be looking like this. Again, just make sure it's not pointy. And trying to be symmetrical here about the y-axis. All right, so something like that. Pardon me again. But very, very rough drawing. All right. And again, let's take a look. All right, let's look at this on the Desmos site. All right, so the function that was given, f of x equals 5x squared plus 2. And see that? The y-intercept is also the vertex, right? 0, 2. And it's opening up, so it's not hitting the x-axis, right? There are no x-intercepts. And those other points I plotted should be on here as well, right? 1, 7 should be on there. Negative 1, 7, right? Those should be on there as well. And you see that. And you see how they're symmetrical about the y-axis, right? This is 1 unit to the right of the y-axis. This one's 1 unit to the left. And the entire graph, the entire parabola is, maybe I should change the color here. Change the color of the parabola. Let's go red. All right. But the entire parabola is symmetrical about the y-axis this time. Fantastic. All right. So our drawing looked good. Okay, next question. Same stuff every time. I got a bunch more of these. So f of x equals 3x squared minus 6x minus 1. It's in that standard parabola, standard quadratic form. A is positive 3, B is negative 6, C is negative 1. The lead coefficient is positive, so that means this parabola is going to be opening up. All right, the vertex will be the lowest point on the graph. All right, now let's find the axis of symmetry, AOS, right? That's x equals the opposite of b, so positive 6 in the numerator, divided by 2 times a. 2 times 3 is positive 6. 6 divided by 6 is 1. All right, so the line x equals 1 is the axis of symmetry. So again, I'm going to make a drawing over here of the xy coordinate plane. Go to x equals 1. Make a little dotted vertical line. All right, this is the axis of symmetry for this parabola. Alright, now that I have the axis of symmetry, I should be able to find the vertex of this parabola pretty easily. And it's going to have an x-coordinate of 1, and then the y-coordinate will be f of 1. Alright, so 3 times 1 squared minus 6 times 1 minus 1, that's 3 minus 6 minus 1, that's negative 4. Alright, so input 1, output negative 4. So here's the vertex. All right, now notice the vertex is below the x-axis, and it's going to be opening up. Right, open up. So the graph will hit the x-axis. There will be x-intercepts this time. All right, so now for the intercepts. The y-intercept is no problem. Right, you put in 0 for x, you would get negative 1 for y. So 0 input, negative 1 output. There we go. Right, and we can use the symmetry to find another point, but I'll get to that in a little bit. Now the x-intercepts, and I'm solving this equation. When is 3x squared minus 6x minus 1, when is that equal to 0? All right. Now you can solve this with the quadratic formula, or by completing the square. I haven't done completing the square in a while, so let's do that. So I'm going to take my get my quadratic term and linear term on their own side, and then add 1. Get the coefficient of the squared term to be 1, divide everything by 3. X squared minus 2x equals 1/3. And then I complete the square by taking half the linear coefficient, which is negative 1, and then squaring it, which would be positive 1, right? And I add that to both sides. Makes this side a perfect square trinomial that can factor to x minus 1 squared. 1/3 plus 1 is 4/3. Using the square root property, we get x minus 1 equals positive or negative, square root of 4/3, which would be 2 divided by the square root of 3, which when you rationalize would be 2 times the square root of 3 divided by 3 if you rationalize the denominator. And then I add 1 to both sides, and we get the two solutions. We get positive 1 plus or minus 2 times the square root of 3 divided by 3. All right, so the x-intercepts are 1 plus 2 times the square root of 3 divided by 3, comma 0, and 1 minus 2 times the square root of 3 divided by 3, comma 0. All right. Now I'm going to put these in a calculator. We'll get an approximation here, and I'll round it to 3 decimal places because that's what the Desmos site does. So I'll pull up a calculator. Our intercepts here are at 1 plus 2 times the square root of 3, and then that second term is also being divided by 3. So about 2.155 if I round to 3 decimal places. This is about 2.155 comma 0. Then the other one, I'm just going to do the same entry, second entry here, and then change the plus to a minus. we get about negative 0.155 comma 0. Alright, cool. Alright, so I'll plot those points as best I can. I mean, they're not perfectly whole numbers or anything. But let's go back to my paper here, and I'll make a rough sketch. So one of the x-intercepts is a little bit more than 2. Right? So there's 2, there's 3, and one of these x-intercepts just a little more than 2, like 2 and 1/10, maybe about there. That's the 1 plus 2 root 3 over 3, comma 0. And then the other intercept is a little bit to the left of 0, right? So here's 0, and then say here's negative 1, a little bit left of 0, negative 0.15, so like maybe around here. All right, and based on symmetry, the distance from the axis of symmetry to one intercept should be the same as the distance to the other intercept. All right. And now we use symmetry to find other points. Right? We have enough right now, but then we can use symmetry. Use symmetry. I'm just going to use this y-intercept here. Right? This is at 0, negative 1. That's 1 unit to the left of the axis of symmetry. So if I just go 1 unit to the right, I'll get another point, 2, negative 1. Right, there's the ordered pair 2, comma negative 1. And check it out. Replace x with 2 in the function. You'd get negative 1 as an output, I promise you. And now that I have all these points, right, the vertex, and I've got some intercepts, points, as long as you have the vertex and some points on, and a point on both sides of the axis of symmetry, again, you should be able to draw a rough sketch of the parabola. And again, don't make it pointy. All right, so there's something like that. All right, something like that. All right, let's check it out. Right, let's see, test our work with the Desmos calculator. So again, I'll enter our function. F of x equals 3x squared minus 6x minus 1. And look, it's got the vertex, 1, negative 4, which we said the vertex was. Y-intercept at 0, negative 1, which we had. And then look at these x-intercepts. See, 2.155, comma 0. Remember, that was the 1 plus 2 root 3 over 3, comma 0, rounded to 3 decimal places. That's what I got on my calculator earlier. And then the other one should be at negative 0.155, right, comma 0. And you see that, right? That was the 1 minus 2 root 3 over 3, comma 0. Fantastic. Right, so it looks like our parabola matches this. And if you want to, put in the axis of symmetry, you can, but I'm gonna stop doing that. We did a good job. Great. All right, next question. Same stuff. Same stuff. All right. Got f of x equals negative 4x squared minus 6x minus 2. That's in the form I want. Ax squared plus bx plus c. A is negative 4. B is negative 6. C is negative 2. So I notice that the lead coefficient this time is negative. So this parabola is going to open down. Right, frowny face. So the vertex will be the highest point. All right, next I find the axis of symmetry. It's going to be x equals, the opposite of b, so positive 6 in the numerator, divided by, and then 2 times a is, negative 8 in the denominator. And this simplifies to negative 3/4, negative 0.75, if you want to put a decimal. All right, so x equals negative 3/4. Okay, so not a nice integer like all the problems so far. but still doable. Right. So x, y. So here's -1, let's say, on the x-axis. -3/4 is 3/4 of the way between 0 and -1. So maybe about here. Let's say that's -3/4. Sorry about the tininess of that. Alright, and then I'm going to do a little dotted vertical line at this x equals -3/4, and this is the axis of symmetry. X equals -3/4. Now we'll find the vertex. Now I know the x coordinate of the vertex is going to be -3/4 or -0.75. And we plug it in. What is f of -3/4? So that's -4 times -3/4 squared minus 6 times -3/4, and then minus 2. Right. This would be 9/16, but times -4 would reduce to -9/4 for the first term. And I'm just going to keep everything with a denominator of 4. Right? You can't add or subtract numbers unless they have the same denominator. So -9/4, and then negative times negative would be positive 18/4. And then 2 is 8/4, right? Minus 8/4. Right? Just getting everything to have a same denominator. Putting them all together, right, we get this common denominator of 4. And -9 plus 18 is +9. Minus 8 is 1. So input -3/4, or 0.75, -0.75. Output is +1/4. So let's say this is 1 unit on the y-axis, and we'll go 1/4 of the way up. There's 1/4. So right here, there's the vertex at -3/4 input, +1/4 output. Okay. And notice, the vertex is above the x-axis, and it's opening down. Right? So from here, this would be the highest point, and all the other points would be below it. So the parabola will hit the x-axis. There will be x-intercepts. Well, let's find those. All right, so for the intercepts, now the y-intercept is easy. That's just input 0, output -2. All right, input 0, output -2. So 1, and then so -1, -2. Right, so input 0, output -2. There's the y-intercept. And we'll use symmetry to find a point on the other side in a second. And then the x-intercepts, we're solving the following equation. When is -4x squared minus 6x minus 2, when is that equal to 0? Right? What values of x give me an output of 0? Now, one thing I'm noticing here is that all these are multiples of -2. I'm going to multiply both sides by -1/2 or divide both sides by -2, and that gives me 2x squared plus 3x plus 1 equals 0. And here we have a polynomial that's nice and factorable. Right? This actually factors to 2x plus 1 times x plus 1. Right? And so my solutions are x equals -1/2 and x equals -1. Right? So the x-intercepts are -1/2, 0, and -1, 0. So -1, 0, there's -1 on the x-axis, and then -1/2 would be another quarter, so about here, right? Halfway between 0 and -1. Eep, right? Real tiny. So -1/2, 0, -1, 0. Right? And then I'll use symmetry to find a point on the opposite side from this y-intercept. Now be careful, right? This is a fraction value. Right? The distance between this point and the axis of symmetry is 3/4 units. So I need to go another 3/4. So to -6/4, which is -1.5. Right? So here's -1, here's -2, here's -6/4, -3/2. That's where the other point will be. So 0, -2. On the other side, you'd have -3/2, -2. Right? -3/2, comma, -2. And I'll leave it to you to check. Plug in -3/2 to the function, and you'll see you get an output of -2. Alright, now that I've got all these points, I can make a rough sketch of the graph. Here we go. And again, just make sure it's not pointy at the vertex. And going through all these points and trying my best to make sure both sides are symmetrical around the line x equals -3/4. And there we go. Alright, a rough drawing of our parabola. Alright, let's take a look at it again in Desmos. Alright, so the function we were given here, f of x equals -4x squared minus 6x minus 2. And look at this. The vertex at -0.75, comma 0.25. That's -3/4, comma 1/4, like we said. This x-intercept at -1, 0, like we said. This x-intercept, -0.5, comma 0, or -1/2, comma 0, like we said. The y-intercept, 0, -2, and then over on this side, you have -1.5, -2, right? As -3/2, -2, which is another point I plotted in my graph. So exactly the same points I had on my graph. This is great. Our parabola perfectly matches this. Great. All right, let's keep doing it. Got just a few more, 3 more. And I'm doing the same thing every single time. All right, so here f of x equals x squared plus 6x plus 8. A is 1, B is 6, C is 8. It's in that form that I want. The lead coefficient is positive, so this is going to be opening up. And the vertex will be the lowest point of the graph. The axis of symmetry. X equals the opposite of b, so -6, divided by 2 times a, divided by 2 times 1. This is -3. Right, x equals -3. And I'll plot this. Right, so here's -3 on the x-axis. Draw a little dotted vertical line, right? This is the axis of symmetry for this parabola. Okay, vertex. X coordinate will be -3. Now this time I'm just going to say them out loud. All right. You'd have 9 plus -18, which would be -9, plus 8 would be -1. If I plug in -3 for x, I'm getting -1 for an output. Right, so -3 input, -1 output. So this point here is the vertex. And we know it's opening up. So that's going to be the lowest point, right? And it's opening up. So that means the parabola is definitely going to hit the x-axis. There will be x-intercepts. And let's find them. Right, the intercepts. Once again, the y-intercept is easy. Just put in 0 for x, you'd get 8 for y. Alright, so 0 for input, 8 for output. There's the y-intercept. And let me just use the symmetry right now. That's 3 units to the right, so 3 units to the left. -4, -5, -6 would also give me an output of 8. So -6, comma 8 should be on this graph. And then the x-intercepts, remember I'm solving the equation, when is the output equal to 0? When is x squared plus 6x plus 8 equal to 0? And this is nice and factorable. This actually factors to x plus 4 times x plus 2. And the solutions are negative 4 and negative 2. Right? So negative 4, 0, negative 2, 0 are my x-intercepts. Right? So negative 4, 0, negative 2, 0. And now I can make a rough sketch of this graph. Again, just make sure it's not pointy at the bottom. Right? So, yep. And then flowing through as smoothly as possible to that point up there, and then continuing on. And then same thing over here, trying to keep it as symmetrical as possible around the line x equals negative 3. Right there we go. That's, again, a very, very rough drawing. I think I messed up here. A rough drawing, though, of the parabola. All right, let's just double check our work. Go into the Desmos site and enter the function we were given. All right, f of x equals x squared plus 6x plus 8. And let's make sure these points all match. Look at the vertex down here, negative 3, negative 1. Excellent. The x-intercepts, negative 4, 0, negative 2, 0, right, as I stated. The y-intercept, 0, 8. Perfect. And then this point over here, you can probably see as negative 6, 8 right there on the other side of the axis of symmetry at x equals negative 3. Fantastic. All right. Our parabola looks very much the same. Wonderful. All right, let's do it again. Number 8, exercise 268 from the text. F of x equals negative 16x squared plus 24x minus 9. It's in the ax squared plus bx plus c form that I want. A equals negative 16, b equals positive 24, c equals negative 9. The lead coefficient is negative. So this parabola is going to be opening down. So the vertex will be the highest point of the graph. All right, now the axis of symmetry. X equals the opposite of b, right? So negative 24 divided by 2 times a, 2 times negative 16 is negative 32. And these have a common factor of 8. This is 8 times negative 3. This is 8 times negative 4. Or negative 8 times 4, negative 8 times 3. This reduces to positive 3/4. All right, x equals positive 3/4. All right, and I'm going to draw coordinate plane. And 3/4, let's say this is 1 here. All right, 3/4 is 3/4 of the way between 0 and 1. So say about here, there's 3/4. Just eyeballing it, right? This isn't perfect. And then making a nice dotted vertical line at x equals 3/4. All right, now the intercepts. Oh, vertex, sorry. Vertex first. Now that I have the axis of symmetry. The x-coordinate will be 3/4. All right, and the y-coordinate is going to be what do I get when I plug in 3/4? Well, 3/4 squared is 9/16. So this is negative 9. Plus that negative 9 would be negative 18. And then 3/4 times 24 would be positive 18. You get 0. 3/4 comma 0. So the vertex here is also the x-intercept. Right, and that's going to be the only x-intercept. Because if that's the vertex and it's opening down, right, all the other points are below that. So there aren't any other points on the x-axis at all. That's the only point on the x-axis, right? Only x-intercept. Great, so I don't need to bother finding x-intercepts. But I will find the y-intercept. We don't have that yet. So the y-intercept, again, very simple, would be at 0, -9. 0, -9. And again, I already know the x-intercept. So now I'm just going to use symmetry. Now, don't forget, this is a fraction. Right? 0, -9, that's 3/4 units away from the axis of symmetry. So then I go to the right another 3/4, which would take me to 6/4, which is 3/2, 1.5. So here's 1, here's 2, here's 6/4, or 3/2. Right, that's where the other point on the other side will be when I reflect 0, -9 across the axis of symmetry. Right, this point here is the point 3/2, comma, -9. Right, and I leave it to you to check that if you wish. Plug in 3/2 for x and you'll see that you get an output of -9. Alright, and now that I have the vertex and some points on either side of the axis of symmetry, I can make a very rough sketch of this parabola. Again, just make sure it's not pointy. Yeah, this is not very good looking. And try to make the other side look as symmetrical as possible. Alright, there we go. Alright, this parabola opening down like that. Alright, let me just test this out, make sure the intercepts and vertices and all that are the same. Make sure I did an okay job with my hand drawing. So f of x equals, we have -16 times x squared plus 24x minus 9. Alright, and look, 0.75, comma 0 for the vertex, and the x-intercept, which is 3/4, comma 0, 340, which is what we had. And then the y-intercept is clearly here, right, at the point, the highlight there is 0, -9. Right, and then the other side, right, reflect across to the other side, you get 1.5, -9, right, 3/2, -9 as I had on my drawing. And it's opening down. Everything looks great. Wonderful. Alright, I got just one more of these. Right, and again, I'm doing the same steps every time to graph these y equals, ax squared plus bx plus c quadratic functions, these parabolas. So f of x equals -2x squared plus 8x minus 10. So a here is -2, b is +8, c is -10. Once again, I'm noticing the lead coefficient is negative. So when I graph this, it's going to be a parabola opening down. Right, so the vertex will be the highest point on the graph. Right, next, the axis of symmetry. X equals the opposite of b, -8, divided by 2a. 2 times a is -4. And this is +2. Right, so x equals +2. Make a xy plane over here. And if you have graph paper, right, it probably look better than what I'm drawing. X equals 2, right, there's 2 on the x-axis, and just making another dotted vertical line here. Right, there's the axis of symmetry for this parabola. Now the vertex, right, the point of the parabola on the axis of symmetry. Well, it's going to have an x-coordinate of 2, and the y-coordinate is, when I plug into and get an output. So it's -2. Right, it would be negative, 2 squared is 4, or -2 times 4 is -8, 8 times 2 is 16, -8 plus 16 is 8, minus 10 is -2, right? So input 2, output -2. So here's the vertex, 2, -2. And notice that it's below the x-axis and the parabola is going to be opening down. So this is the highest point. That means there are no x-intercepts. So when I go to state the intercepts, the y-intercept is no problem. The y-intercept would be 0, negative 10. But the x-intercepts, there are none. No x-intercepts, no points of this graph on the x-axis. Now, if you were to try, say you didn't see that, and you were to try solving the equation, negative 2, when is negative 2x squared plus 8x minus 10, when is this equal to 0? You're going to see that the solutions to this equation aren't real numbers. They have an imaginary number in them. Watch. So first I'll divide everything by negative 2, x squared minus 4x plus 5 equals 0. Subtract the 5. I'm going to do this one by completing. You can use the quadratic formula if you want, but I'm going to do this one by completing the square. I'd be adding 4 to complete the square. This is x minus 2 squared equals negative 1. And you see I'd be taking the square root of negative 1 when I solve this. That's that's imaginary, it's not real. The solutions of this equation would be 2 plus or minus I. Not real. And again, if your solutions to that equation are not real, that means that the graph has no x-intercepts, right? The x-axis is real numbers only, right? It's a real number line. All right, well, I at least can plot the y-intercept. This is, again, just eyeball and stuff. It's not perfect. But, 0, negative 10 down here. And then I can use symmetry, right? This is 2 units away from the axis of symmetry, right? This 0, negative 10 point is 2 units to the left. So I just go 2 units to the right, and I get 4, negative 10, right? I get a point on the other side. So here's the ordered pair, the point 4, negative 10. And you can check it if you want. Plug in 4 for x into the function, and you'll see you get an output of negative 10. And now I graph it, right? Again, not pointy at the top. And have it go through these points and continue on. Right? And try to make it look symmetrical. That was bad, all right? That was a bad turn. But yeah, so there's a rough sketch of our parabola. And then once again, just to test things out, check that I did okay, I'm going to go to the Desmos site and enter that function and see if it matches my hand drawing reasonably well. So we had f of x equals negative 2x squared plus 8x minus 10. And look, see, no x-intercepts. See, the graph is, the vertex is at 2, negative 2, as we stated, and it's opening down. So no x-intercepts. The y-intercept is clearly here at 0, negative 10. And if you were to reflect across the axis of symmetry, you get, 4, negative 10. It's there somewhere. There. Right, which I pointed out on my graph by hand. So looks like, again, I did a pretty decent job. It's not perfect looking, but I did a decent job graphing by hand, and you should be able to as well. Right, so now whenever you see a quadratic function of the form y equals ax squared plus bx plus c, you should be able to make a pretty reasonable sketch of that graph by hand, that parabola. Okay. All right, I'm hoping that watching me go through these 9 questions here, 9 examples, helps you out when you're asked to graph quadratic functions on your own. And thank you very much for watching.